Okay, we are trying to find the integral of this function here from 1 to 3. We don't know what it is. We're just going to call it f of x. All right, but we're given parts of it. All right, we're given one part which says from 1 to 2, we know that this thing is going to be equal to 3. And we're giving another part from 2 to 3. We know that this thing is going to be equal to 5. Okay, let's just break it down nice and simply with a more simple function. Let's just call this, let's just call it like y is equal to 2x. Oh, like this. Okay, so if we try and find the integral from 1 to 3, and we shade in that area, right, we can also say that we can split that up into two separate components, say at point 2 here, and we can add them up. So if we find the integral of 2x from 1 to 3, all right, you can figure this out if you want, but what we can do is we can say that that is equal to the integral from 1 to 2 of 2x, right, plus the integral of 2 to 3 of 2x there. So I'm going to work this all out. So let's find the integral. We get that 2x to the squared business, all divided by 2. So that cancels out that value of 2 there. And we go from 1 to 3. Okay. Just going across here, we can figure out this value so that it becomes 3 squared minus by 1 squared, and that is equal to 9 minus by 1, which is equal to 8. Okay, so that's the value here. This is our temporary function, just like an easier question as a bit of a warm-up. So we can do the same thing here. And so in this case, we get that x squared from 1 to 2 plus the x squared from 2 to 3. If we figure that out, we get 4 minus 1 plus a 9 minus by 4. We can see those guys cancel out, and so we get that being equal to 9 minus 1, which is 8. And hey, that was the same question that we got before. So we are we can see that we can split it up. So we've got this component here, that 3, which is kind of like from 1 to 2, and that 5, which is kind of like from 2 to 3. Now there's this other thing that we can do, right? We can grab that, like there's a 2 here, and we can just move that out the front. It's a constant. So let me show you why that works. So let's find an integral, let's say, of 2x from, well, let's say 1 to 3. Okay, let's move that 2 out the front. It's just a constant. It's all okay to do that. And let's just find the differential of that guy. And you can see that it's basically equal to the same thing. We get that x squared divided by 2 from 1 to 3, and that becomes 8 over 3 minus by 1 over, so 8 over 2 divided by minus 1/2 there. And if we keep simplifying this all out, we will get something that we're used to. So that 8 divided by 2, which is that 4 business, minus that 1/2. And if we expand this back out, we get that's equal to 9 minus 1, which is equal to 8. So the trick about this particular question here is that when we go back to the original question, we can say, actually, that 2, for that unknown function that we've got no idea about, we can just bring that out the front. Nice. And then the other component of it is that we can split it, like we did the other one, we can split it so that it becomes from 1 to 2. And we know the answer to that, plus 2 to 3. We know the answer for that, and that is equal to this value here. So it's a little abstract, but it's just making sure you understand how you can split things up and move the constants out the front. It's a good test of your understanding of integration and differentiation. So tough question, but once you know the trick, it's nice and easy. Hey, I've got heaps of questions on my website. If you want to practice, jump on the link below. There's so many more like this. They're exam level questions, they're tough. But if you do them all, you get really good and have a really good chance of getting a high score or passing in your exam. So go ahead, do it. And if you have any questions, reach out in the comments or message me. I would love to help.